Good morning, everybody. That's a little lame. Good morning, everybody. That's a lot better. How's the Build conference going so far? Awesome, isn't it? Yeah? Well, this is going to be the best session you're going to have seen all day. I want to welcome you all to Build, welcome you all to an exciting new world of development. I want to welcome the online viewers that are watching this live and those that are going to watch this in the recorded version of this. That's why we had such a orchestrated start to the session here. What I'm going to talk about is Azure's next generation compute platform. We've got a bunch of announcements to make in this session and a bunch of really cool demos to show you in this session as well. This is the way that I've structured the session to kind of take you from the very top level, because we can't talk about compute without talking about Azure's overall application model, which we call the Azure Resource Manager. I'll talk about that. For those of you that might not be familiar with it, it is something that is already GA'd, but what I'll do from there is take you into some of the new APIs that are plugged into Azure Resource Manager that we're announcing today. And those are around virtual machines, storage, and networking resources, completely changing the way that you interact with these types of resources in Azure. And then I'll talk about Service Fabric, which we pre-announced last week with the blog post. What you're going to get here is an SDK to play with Service Fabric. For those of you that didn't see the blog, maybe don't know what Service Fabric is, I'm going to give you a pretty detailed overview of Service Fabric, which we're really excited about, which is a microservice-based orchestration platform. Now let's go ahead and get started and talk about Azure Resource Manager. Just out of curiosity, how many people have used Azure Resource Manager? So just a few of you. Those of you that have been using Azure for some time have probably been using cloud services and the existing portal. Well, Resource Manager is a different way of looking at cloud applications. Let me set some context here, because if you take a look at the original cloud service application model, you know that it was just focused on compute and network, and it left a lot of the glue of connecting other types of PaaS services, including even just storage to those VMs that you were putting into your cloud services, up to you. If you wanted a website, you deployed a website, and then you deployed a database, and it was up to you to glue those together. With Azure Resource Manager, we've defined this concept of resource grouping, where you can group collections of resources together that make up a whole application or part of a larger application. Each resource instance that you put into a resource group is of a resource type. And I've already mentioned some of the resource types, like virtual machines, like databases, like storage accounts. And those resource types are defined by what we call resource providers. The Azure Resource Manager is completely extensible. So it comes with a number of built-in resource providers that define their own resource types. But when we want to add a new resource provider to the Azure platform ourselves, there's no need to go change Azure Resource Manager other than register the new resource provider and the types that it's going to support. We've already onboarded some third-party resource providers as well, and you'll see us light up the onboarding process so that others, more and more, you can onboard your own resource providers into this model. Now, one of the concepts here that we're sticking to is that resource groups are a concept that's deeply baked into the platform. There's no such thing as a resource now in Azure that is not part of a resource group. So when you want to just create a storage account, if that's the only thing you're interested in, you're still putting it in a container, which is a resource group. What you get by putting these things in these containers is that you get lifecycle management of the whole collection of resources that make up this logical entity that you're interested in grouping together. So you get the ability to deploy them all together. And I'll show you how we support declarative deployment of resource groups. You get to update them together. So if you've got updates that span a bunch of these resource instances, those updates can be done through single APIs into Azure Resource Manager. You can delete the whole resource group together. So this is a way for you to say, I'm done with all this application or this part of this application. Delete it, and all of the constituent resources get deleted automatically. And then you can query the status of the resource group, the aggregated status of the resource group, and then you can drill into the resource group and query their status as well. This grouping is useful in other places too. For example, you're going to see us add more and more capabilities around putting in metering and quotas on resource groups, so you could say that this resource group can only create N number of VMs and no more, or only create X amount of storage in storage accounts and no more. You'll be able to set billing limits on resource groups. You'll be able to also, and this is already there, take a look at your resource group status, from this collection perspective, from the portals to the command lines, interfaces to Azure, to the REST APIs, as well as PowerShell. And then it's also a scope for RBAC. So this is the way we're introducing RBAC into the control planes of Azure, is through Azure Resource Groups and Azure Resource Manager, where you can define RBAC rules that are scoped to a resource group or to resources or even sub-resources in a resource group. So you could say that only the owners of the resource group can have read-write access to the VMs in the resource group, for example. And then something that you're going to see us coming is identity is going to be built into resource groups too. So resource groups will have their own identity provision in Azure Active Directory. And using this identity, all of the resources in that resource group will have the ability to talk to each other without you having to provide credentials or certificates for them to have some identity to talk to outside services. They will appear as first-class principals in Azure Active Directory. This will allow them to talk to each other, these resources inside the resource group, as well as to outside resources that are able to speak the OAuth protocol to interact with these. Now, one of the questions that I often get when I talk about resource groups is, I've got some resources, when should I put them in a resource group versus put them in separate resource groups? And the answer to that question is actually fairly simple and straightforward. Do they have common lifecycle and management operations that you want to perform on them? If, for example, you've got a marketing database and you've got two front ends to that. Maybe one is an internal front end that's going and putting data in the marketing database, and the other one is a customer-facing application that's also making use of that data in that marketing database. Well, those are three different resources that likely have different life cycles, and so you want to put those each into separate resource groups. Now, the front ends, though, might have their own middle tiers that are part of them, that are part of that life cycle of that front end, and so you're going to put those inside the same resource group. The Resource Group Manager services. So Resource Group Manager, there's a front end to Azure. It's called the Resource Group Manager. And it provides a bunch of services that all of the resources that are part of this model get for free. For example, centralized auditing of operations. Because it is the control plane to Azure, you get basically a log of all the control plane operations. And I've got a screenshot there from the Azure portal showing you that. You get tagging of resources. So this is useful if you want to be able to tag resources and then perform queries like which resources are tagged marketing department, because those resources are related to whatever the marketing department's doing, and you can, by tagging resources, do those kinds of queries. This tagging will also be integrated into the billing system so that you can go and say, how much did the marketing department cost me last month? And by evaluating those tags and looking at the bills for those resources over the last month, you'll see a summary of how much that cost you. And then finally, like I mentioned, it's a consistent place for RBAC with a number of built-in roles, and then resource providers can define their own roles for themselves, for their own resource types, all implemented in a consistent way through this control plane. One of the most exciting parts about Resource Manager, though, for me, is the fact that it's got templatized deployments. So you can interact with Resource Manager using REST APIs and perform imperative operations that build up a resource group. So for example, you can say, go create a VM and then create a storage account, both in the same resource group. But we've moved into a world where imperative creation of resources, of applications, is something that is non-reproducible and fragile. And so we've gone to, at least within Azure, a more declarative approach to defining what applications look like. And with this declarative approach comes the template that describes exactly what you want the application to look like, in this case, a resource group. So for example, I want a website with a database, and I want the database connection string to go into an input parameter on that website. Instead of me having to do something out of band, by putting this in a template, I can describe those relationships and give it to Azure Resource Manager. I can parameterize the template so that I can deploy it into multiple places and get the same experience everywhere I go just by supplying different parameters depending on the environment. So I can deploy it into a test environment with test parameters. I can deploy it to a production environment with production parameters. I might want a single instance version of my application in test, but in production I want it to be multi-instance for scale out and for availability, and I can do that just by changing parameters. But the template itself, describing the structure of the application, is unchanged, and I can check it into source control. the way that the template execution works, Azure Resource Manager takes a look, and this is another advantage of having something that's declarative rather than imperative, is that the Azure Resource Manager can examine the relationships between the resources that are in the template and find the fastest path forward to get that operations executed. So for example, I've got an app service plan, which is what I deploy web apps and logic apps onto. I might deploy a website onto it. I put auto-scaling on top of that. After that completes, there's some dependencies some resources that had dependencies on that website coming up, like app insights, an alert rule on the website, CPU usage, and maybe an MS deploy package is dependent on the website coming up before those can activate. And then that all completes. And you can see some of these deployments, some of these activations were done in parallel. Other ones were serial. You did not have to worry about that. Simply by specifying the relationships, Azure Resource Manager takes care of that for you. So let's take a quick look at the built-in support for Azure Resource Managers that is right in Visual Studio, so enabling you to get started with Resource Managers really easily. And to do that, I'm going to go to New Project here. And in the Cloud section, you can see that there's this Azure Resource Group here. I'm going to give it the default name. And Visual Studio has some canned resource templates built into it. I'll pick Web App plus SQL because this shows us a multi-tier type of application described as a resource group. Now, if I go over here to the Azure Resource Group solution, I can click on the JSON describing that application. And this is the template underneath a database plus a SQL server. Over here, we can see a JSON outline, which is conveniently allows me to look at the resource types that are inside of this template. And there's a number of them in addition to the ones that seem obvious, like the website and the database. We've got a SQL server, and we've got a database. And you can see as I click, it's navigating through the JSON. You can see here's a resource. And there's some interesting things to note here. For example, the type. This is a database type. It's actually a subset of the Microsoft SQL namespace. It's going to deploy to a specific location. So I can have resource groups that span multiple locations, meaning multiple Azure regions. I can say this thing goes to East US, and this other database, part of the same template, that goes to West US. And that will allow me to create in a single template DR or highly available application that spans regions in Azure. And then you can see properties down here with references to what are called parameters. Now let's take a look at what parameters are. Like I mentioned, you parameterize your resource group, and this allows you to customize it, customize this template for whatever environment you're going to. You saw some references here, like, for example, the size of the worker in the website. Now, how big can the worker role be, or the worker be, rather? You see the allowed values are 0, 1, and 2. It's a type string. The default value is 0. So if no parameters to specify, here's the default. But it also, any tooling can look at this and know that it's going to enforce I don't put a 3 in there. Now, what I'm going to do here is to show you just how Visual Studio helps you deploy this thing. So I've created and provisioned my Azure subscription here. And when I go deploy it, one of the things it's going to ask me is for the new resource group name. But I can also edit the parameters right here inside of Visual Studio. So this is looking at the template and saying, hey, you need to provide some of these values. You can see the worker size here was defaulted to 0, as specified in that parameter section of the template. So let's switch back to the PowerPoint and get a little more detailed about what we're doing in those templates. So quickly, just to review, there's some things that you saw in there. Parameters. Those are the templatized parameters that allow us to specify values from the outside in a configuration file. There's variables, which are basically macros of values that I can then use in multiple places inside the template instead of having to put the same expressions all over the place. The resources that we mentioned, and then there's output values. So templates can produce output values that then can be looked at through tooling or through UIs that will tell us what are the interesting things that came out. For example, when I go deploy the website, well, what's the URL of the website that popped out of that resource group template as I deployed it? That can be an output parameter emitted by the website itself into that resource group, and then I can go take a look inside of a portal, for example, to see what URL to hit to see that website. And then there's some DSL that you'll see here in templates that allow us to create expressions. For example, one of them is this parameters expression, which references a parameter. You can see this reference from the second one up there, that lets us reference an output value from one resource into another one. So that connection string, that SQL connection string I mentioned, I want to reference from the website configuration for SQL connection string the output of the SQL database, which is going to be its connection string. And that I do with the reference value. So that's a quick overview of Azure Resource Manager. Let's talk about some of the announcements we're making here at Build today, which are really exciting. It's around the new support for virtual machines, storage, and networking APIs as part of this Resource Manager family. Up to today, we've had a number of resources already plugged into Azure Resource Manager. You saw websites, you saw Azure Database in the example I just showed you. Redis Cache is another one. There's 40 more. Microsoft first-party and, like I mentioned, some third-party, like SendGrid, for example, is a third-party resource provider, so you can provision a SendGrid endpoint as part of a template, and that would then allow your website to be able to send email without you having to go pre-provision that yourself. There's also version 1 of network storage and networking APIs built into Azure Resource Manager today. But let's talk about what's new about version 2. So version 1, you can go, and if you create in the portal, which I'll show you in a minute, a resource group, you will see, or a virtual machine of V1 type, it will go into a resource group. But it's not a first-class citizen of Azure Resource Manager, so it has no RBAC support, it has no tagging support, it has no templates. So it's really kind of a visualization, a kind of weak link of that resource into the resource group. And it's got clunky network modeling. If you're familiar with our networking APIs, and maybe you wanted to have a NIC, for example, that was separate from a virtual machine, or a load balancer that was separate from a scale-out set of virtual machines, you didn't have that option. Those were baked into the compute model. So what we've got with version 2 is direct integration into Azure Resource Manager. So all of the things that I've been talking about with Azure Resource Manager just light up. You get a revamped control plane now that we've put in here to implement these resource types, which overcomes some of the serialization limitations of the version 1 implementation. So if you've ever done multiple operations and maybe had a lock where you couldn't go update your cloud service because something was in progress, you wanted to add a disk to a virtual machine, but the virtual machine, those are all gone. Everything is fully asynchronous. So you can go be modifying virtual machines while you're modifying the network adapters for them, while you're modifying the virtual disks for them at the same time. All of that is then just asynchronous operations you give to the control plane. And then, really excited to say that these new APIs are part of the Azure Consistent Private Cloud experience that we're delivering and that we're committed to delivering. And I'll talk more about that in a second. Like right now. Let's go take a look at these new APIs. So we'll switch over to the demo machine. Now, what I've got is a template here. This is a coffee shop application. And I've got the template here in Visual Studio. If I click open, you can see there's a bunch of resources in here. We see a SQL server. We see a website just like we saw before. But here we see version 2 of these virtual machines. We see the NICs as well. And when I click on the virtual machine, we can see that these are fully parameterized. So I can see I parameterized the size of the virtual machine right here. I parameterized things like the admin user account and password. So these are going to be asked for at the time I deploy the template. I've even specified where the disks go, into what storage account in a parameterized way. And then there's a variable here, a macro basically to source WinImageID. If I go to source WinImageID's variable, you can see that this is a concatenation of some subscription information. And then there's a parameter here, WinSourceImageName. So it's actually going to ask me, when I deploy this thing, what the WinSourceImageName is. But there's a default. And you can see that's a Linux virtual machine. Oh, sorry, I clicked on the wrong one. Here, you can see this is a Windows virtual machine. This is Server 2012 R2. So there's defaults here specified. I can overrule them and specify other images. Now I'm going to go deploy this in PowerShell. And here's the PowerShell commandlet to deploy an Azure resource group. You can see I'm naming this one Mark's Coffee 24. I'm specifying East US. Here's the JSON file. And then I'm specifying, as part of this deployment, a parameters file. So let's go take a look at that parameters file, which is right here. And I've simply filled in those values that are required. Like I mentioned, the username and the admin password. You can see there's no password there because I didn't want to show you what the password really is. But if I press F5 now, this is, whoops. I've got to switch to Azure Resource Manager mode here. and I press F5, and now this is going to be launching this to East US. I'm not going to wait for that to finish. I've already deployed one of these resource groups of that template here, Mark's Coffee. You can see Mark's Coffee 24 is being deployed. I'm going to click on Mark's Coffee, and let's take a look at the resources that are part of it that match the template. So I click on Resources. Here's the list of resources, exactly like we saw in the template, exactly like we saw in Visual Studio. Down here, you can see there's a storage account. So this is the version 2 of the storage control plane APIs. Here's the blob, and there's one blob in that account, and that is storing a VHD here, which you saw the full parameterization of that VHD as I provided in that template. When I go back and take a look at the web app, right in here, I've got a browse experience just to show you that this thing really is live. There's the coffee shop app that was deployed as part of that template. So that's fantastic. I deployed that to the Azure public cloud. But this coffee shop business that I'm going to get into, coming from Seattle, I know a thing or two about coffee, and I think there's a space for a little neighborhood-type coffee shop, maybe not near San Francisco, but maybe someplace else. And what I want to do is deploy the same coffee shop app to a location where I've got my little coffee shops sprouting up that maybe Azure isn't reaching yet. I want to deploy it to a private cloud. I want to take that same template and deploy it to a private cloud. So let's go see how I can do that. I've got that same template here, coffee shop JSON. I'm deploying it here. I've got Azure set environment. This is against Azure Resource Manager. I've added my own coffee shop private cloud endpoint. I've got a subscription at that endpoint, build demo. And when I launch this thing, it's going to ask me the resource name. So a coffee shop. Let's make it just some random number. And now this is going to start deploying to Mark's cloud as part of this endpoint for Mark's private cloud. Again, we're not going to wait for that to finish. Let me go and take a look at Spartan. Still getting used to that UX. Now, this browser is pointing at Mark's private cloud, where I just started that deployment. When I go to Browse All, here's the resource groups. There's Mark's Coffee Shop 30 in the process of deploying. Let's click on the one that's already deployed, Mark's Coffee. And this is going to look very much like what we saw in the public interface. Off the same template, the same resources, the same APIs, I can go click on the storage account and take a look at the blob. And here's the blob, now not in public Azure, sitting in the blob storage account of my private cloud. And if I go back to the website, I get the same exact portal experience. I click it open, and I've opened Mark's Coffee Shop running in Mark's private cloud. Same template, parameterized differently, private cloud deployment. So let's switch back to the PowerPoint. Now, what I've shown you is the introduction of virtual machines into this new Azure Resource Manager API. And what I'm going to do for the rest of the session is take you up the layers of the stack to show you some of the capabilities that we're enabling as we build this into the system. I've shown you Azure Consistent Private Cloud. I've shown you Azure Public Cloud and the fact that I can take a virtual machine and deploy it to either one of them. You'll see in here in this label, though, it says virtual machines and virtual machine scale sets. So let's talk about what are virtual machine scale sets. This is a forward announce of a preview that's going to be coming in a few months of VM scale sets. So those of you that have used worker roles or web roles, how many of you have used worker roles or web roles in Azure? So a lot of you have, and you probably have run into some of the limitations of web and worker role. As powerful as they are for stateless scale-out applications, for easy elasticity and reproducibility because they're all just golden images, the limitations include the fact that you can't pick a custom image. There's no support for Linux, for example, in web and worker role. So what virtual machine scale sets introduces is basically next generation worker role. You don't need to put your own runtime in there. It's basically exactly as a virtual machine, except it's stateless, and you can scale it out very easily. You can start with a golden image. It supports golden image-based updates of the OS. So you get reproducibility and consistency of the experience. And it's great for clusters. So speaking of clusters, here's just a little graphic to show you these things scaling out. But speaking of clusters, let's talk about virtual machine extensions and how this enables third-party cluster orchestrators to layer on top of Azure. With virtual machine extensions, you've got the ability to dynamically inject code and configuration into virtual machines, either at the time that the virtual machine is provisioned or even afterwards. And you can even update the code or configuration. We previewed this basically about a year ago, and this is part of the new virtual machine APIs as well. You can stick things in like Chef and Puppet and DSC. You can stick in things like monitoring agents, backup agents. We just announced a backup service for Azure virtual machines, which make use of the backup extensions to inject a backup agent. You can stick security agents in there that do BitLocker encryption, that do WAF. Basically, it's left to the imagination for what kind of code you want to layer. And the benefit of extensions is that you don't have to bake this stuff into an image. You can take any stock image that's compatible with these extensions and layer them on after the fact. So no more having to go and have image sprawl just because you want a monitoring agent inside of your images. Now, what this enables is for third-party cluster orchestrators and PaaS application frameworks to bootstrap themselves into these virtual machines using virtual machine extensions. And again, they don't have to bake all this stuff into the virtual machine. They can take advantage of the extension model to get themselves bootstrapped, and they also then get the benefit of having anything else that works as an extension work side by side with them, like antivirus. You can see here, scrolling up, there's support for Scalar, RightScale, Mesos, Swarm clusters, and then those can bring in their own PaaS layers on top, because those are cluster orchestration systems that PaaS application frameworks layer on top of, like Apprenda, Cloud Foundry, Elastic, Marathon are some examples. And now what I'm going to show and announce here is through a great partnership with Mesosphere, is if you're familiar with Mesosphere and its support for Mesos clustering, they have a new cluster orchestration platform called DCOS. And DCOS has been in private preview. Today, they're announcing public preview. And the first place it's public previewing is on Azure, built into templates. And what I've got right here is showing you GitHub with a Mesosphere template here. Corey here. There's Corey Sanders. He just modified this an hour ago. He's a program manager on the virtual machine team. And what we see here is that template for a Mesosphere cluster. So this is a highly available Mesosphere cluster that you can deploy with this thing. If I scroll down, the interesting parts here is how do we make this thing a high-scale cluster? Well, here's a type Microsoft Virtual Machines. You can see that it takes a name as a parameter, takes a location as a parameter, but then it's got this interesting thing, which is a new addition to Azure Resource Manager, which is the ability to basically create loops over resource instantiation. So this is the master VM loop for the master nodes in that Mesosphere cluster, and the count is parameterized. So I can say that I want 10 or 3 Mesosphere masters. I can say I want 1 because I'm just doing dev test and I don't want a big deployment. And you can see some dependencies on some other resources in here. And down in the OS profile, you can see an example of some of the extension support we've added, which is custom data that gets piped into the virtual machine through a Cloud Init type interface so that this gets bootstrapped. The Mesosphere master gets bootstrapped on a base OS image, again, so that Mesosphere doesn't have to continue to maintain OS images with Mesosphere baked in. You can pick a base image and then deploy the cluster into that image. So let's go take a look at that Mesosphere cluster. I'm going to go back to that. And we've built in a deployment experience right from GitHub for all of the templates. And you'll see that we've created probably 100 templates now that are up in GitHub. They all have this deploy to Azure button on it. So once you set up your Azure subscription information, you get this kind of experience, which will open the template up. Now, if I'm happy with this template, I say save. And then I go back to edit parameters. And you see here are the parameters that I need to enter. And so some of them, like the number of the slaves, the number of masters, and we're going to deploy a cluster with 100 slaves. And down here, we need to pipe in some SSH data. Actually, I'm going to just go ahead and skip that because I've already got this a cluster like this already deployed. But I'd specify these other 2 parameters, press OK, and this would start a deployment of a 100 VM Mesosphere cluster to Azure. But let's go ahead and take a look by going to the Azure portal at the pre-deployed one that I've got. And we're going to do a little playing around with the Mesosphere cluster to show you how cool it is to have a container cluster orchestrator on top of Azure Virtual Machine. So I've got here, this one here, DCOS. And you can see it's got 212 resources. These are all the resources, including NICs, virtual machines, the masters, and the slaves that are part of this deployment. Now, I want to interact with this cluster, so I've deployed it, but now I need to interact with the management interface to that, and I can go and find out where the management interface is by looking at the deployment history for this thing, which has the template output parameters. And you can see there's 3 masters that each spit out their own URLs. Now, I don't know which one is the true master of this cluster because one of those 3 is the master. There are 3 for failover purposes. Now, there's a 50-50 chance I've picked the right one. Actually, that doesn't make any sense, does it? There's a 1 in 3 chance I picked the right one, but it's port 5050 the thing's listening on. And you can see I picked the wrong one, and now it's redirected me to the Mesosphere master. And now I'm looking at the Mesos cluster management interface. But what DCOS brings to the table is a higher level management interface on top of Mesos clusters. And I can get to that by simply hitting the URL. And now I'm looking at the DCOS dashboard, which shows me the overall cluster utilization. I can see all the nodes that are part of that cluster and their specific utilizations. But what I want to do is take a look at the custom viewer as I deploy a bunch of containers to this. And we've created a DCOS visualizer working with the Mesosphere team, which will show us containers starting up. And when I come back here, what I'm going to do is add the Marathon application framework to that cluster. And this is already pointing at that cluster that I just got deployed. I'm going to add the Spark, which is another application model. Here, where's add Spark. And now I'm going to launch 1,000 Marathon instances. And I'm going to launch 1,000 Spark instances. So these are all going into Docker containers on top of those virtual machines on top of Azure. And this little visualizer shows you just how quickly these tasks, these application containers, get deployed and launched onto that Mesosphere cluster. So, yeah, you can clap. I think that was the Mesospheres guys clapping. All right, so let's switch back to the presentation. So that's a look at cluster orchestrators on top of that foundation of virtual machines, virtual machine extensions on top of Azure Resource Manager with templates. Now I'm going to take you into, and I already, by the way, talked about containers this morning in the keynote demo. How many people saw that? So I'm assuming everybody did. Sami shows Windows containers and Linux containers with integrated Docker support. There's a full container session that will go into Windows Server containers tomorrow late afternoon. So I'm not going to spend time here. But one of the great things about containers is that they're great for microservice-based applications. And let me just stop here for a second and talk about what is a microservice-based application. A microservice-based application is one application you've decomposed into tiny parts. And you've decomposed it into tiny parts for a few reasons. One is that you can test them in isolation. They can run in isolation. When they put them in a container, you can make sure that when it works on your dev box, it works in production box as well. Now, by decomposing into this fine-grained units, you want to create kind of rigorous interfaces between one of the microservices and the other microservices of the application. And that also helps you evolve those different parts of your application independently. With strong contracts, as long as you don't break the contract, you can change the implementation underneath the hood and even add new functionality without breaking the other microservices that are depending on it. And then have this kind of organic growth of the application in a very lightweight and decentralized manner. You can also update them independently. So if you make a change to one microservice, you're not impacting the whole application. You can scale them out independently. So instead of having to take giant blocks that are all a whole bunch of stuff inside of it. You just want to scale out because you've hit a limit on one of the application components in that big monolithic block. You want to scale out just the microservice that needs to be scaled out, that needs more CPU or more network, and leave everything else alone. And so it has a lot of efficiencies for agile development, for rapid iteration, for ease of management. Now, going and managing all of these microservices is something that you probably don't want to do yourself. You want a microservice manager to do it for you. And it would even be nice if you had an application platform that understood microservices and made it easier for you to write microservice-based applications. And that is where Service Fabric comes into play. It's built on top of that same foundation that we saw the Mesosphere and DCOS clusters and these other cluster orchestrators and PaaS libraries on top of. This is something that we've been working on inside of Microsoft for a long time. And it has a rich set of functionality designed around microservice-based applications. Everything from making sure that it's highly available. It's templatized, just like we saw Azure Resource Manager. You describe a template of your microservice-based application, and that allows Service Fabric to look at what you want and make sure that you're getting what you want. If you want 3 replicas of your front-end microservice and a virtual machine goes down, Service Fabric is going to make sure that it's going to migrate and create that third one that got impacted for you without you having to go worry about that. It supports partitioning for scale out, and I'll talk more about that in a minute. It supports rolling upgrades of microservices. So if you've got those 3 front ends, you don't want to just blast an update to all 3 of them. You want to do it in a careful way that provides availability and safety by doing it one at a time. And if there's a problem with health watchdogs built into Service Fabric or ones that you add yourself, you can get rollback on top of it. It supports private clouds as well as public clouds as well, so you can deploy it on your own systems. You can deploy it to Azure. Here's just a subset of some of the high-level functionality and capabilities of Service Fabric. I've touched on some of them. I talked about rolling update with rollback. It supports strong versioning. So it knows what rollback means because it knows that you've got version 2 of microservice, and version 1 is the last known good one. It supports side-by-side support. So I can even actually deploy version 2 of a microservice on the same cluster with version 1, and Service Fabric will route requests appropriately depending on what the client wants to talk to, version 2 or version 1. It supports leadership election, and this is inherent in something called stateful microservice support, which I'll talk about in a second. Of course, name discovery, that's any cluster orchestrator with containers needs name discovery service so the different parts of the application can find each other. I mentioned it supports partitioning support. It supports load balancing and placement constraints. Now, this is important if you've got a cluster and you're deploying multiple applications to it or a complex application with many, many microservices. You might say that the front ends can't be on the same servers with the middle tier or some other component because they conflict on resource requirements or they conflict in some other way. So what you'll do is set placement constraints to say these microservices can't be co-located with these other ones. You can even do things like these 2 need to be together because they actually have a tight interface, and I want round-trip communication between them to be as fast as possible, so on the local machine where it can be. And like I mentioned, this is the only kind of microservice application platform out there that supports stateful microservices. I'll talk more about what stateful microservices means in a second. But what we're making available is already, like I said, been in use for 5 years now inside of Microsoft to power all of these services. For everything from Azure Database, which is now running 1.4 million customer databases. Let me just highlight what that means from Service Fabric perspective. That means tens of thousands of servers, hundreds of thousands of containers, essentially microservices. Each one of those databases is represented as an instance of a stateful microservice with either 3 or 4 replicas where Service Fabric is taking care of all the state management and all of the healing and all of the updating of those database instances. So 1.4 times roughly 3, that gives you an idea of the number of stateful replica instances that Service Fabric right now, as we speak, is keeping healthy in the Azure cloud. Down to things like Intune and Cortana. So Cortana is supporting, I don't know, however billions of requests per second that people are making on Cortana. All of that is going through Service Fabric. And this isn't what we're giving out as the SDK here today to you, which the URL should be live about now, which I'll show you at the end of the slide. We're not giving you something that looks like what we run internally for this stuff. We're not giving you something that's a rewrite of it. We're giving you the exact same bits. This SDK that you're getting is the same SDK that all of these services use. So that's what got me so excited. Let me just give you an idea of some of the things that it can do visually. So I've got 2 applications consisting of multiple microservices. I've deployed it with placement constraints and load balancing. It's gone out to a cluster of machines. Now, if a machine fails, Service Fabric will automatically heal those instances to other servers. Well, what is a microservice in the world of Service Fabric? It's really whatever you want it to be. It can be an ASP.NET 5 application. It can be a Node.js application. In fact, it can just be an arbitrary exe that you say, this is my microservice, and take it from here. Anything you want it to be. And as I mentioned several times now, there's 2 types of microservices that Service Fabric supports. There's stateless microservices and there's stateful microservices. Now, stateless ones are the ones that we're probably most familiar with. In fact, the whole application model that Azure's been pushing you towards is a stateless one. Stateless worker roles and web roles and ASP.NET web apps. Those all externalize their state to someplace else. And there's a need for stateless microservices in any complex application. Azure Database consists of probably a dozen microservices, and several of them are stateless microservices, like front ends. Then there's stateful microservices. Now here, let's talk about what statefulness means. It means that the code and the compute are co-located together. It's not externalized. They're bound tightly together, and only through this kind of microservice stateful system can you ensure high availability and durability of that state. And Service Fabric takes care of that state management for the developer. That Azure Database, the Azure Database developers, they worry about running SQL.exe. And underneath SQL.exe, they talk to Service Fabric APIs. When SQL.exe wants to make a transaction, they call Service Fabric APIs. And Service Fabric APIs then take care of making sure that the primary, in that leadership election, one of those 3 database replicas is the primary, that state change, that transaction is replicated to the secondaries. The developer doesn't worry about it. Doesn't even worry about the fact that it's on a primary, secondary. The secondaries are tracked by Service Fabric. And if there's a failure anywhere along the way, if there's an update in progress on one of the databases so it's down, Service Fabric takes care of creating a new instance of the database on a healthy server and catching that instance up with the primary and the other surviving secondary. Or if it's the primary that died, Service Fabric picks a new primary, and the name service automatically routes requests to the new primary, providing a stateful, consistent view of data, very easy for the SQL developers to work on. Now, there's 2 different types of APIs. There's multiple programming models you can put on top of Service Fabric. I'm going to talk about 2 that we're releasing as part of this SDK. One is called the Reliable Services API, and the other one's called the Reliable Actors API. And let's talk about the Reliable Services API. Those of you that are familiar with .NET, how many are .NET programmers here? Just raise a hand. So how many of you have ever used a dictionary or a collection? So almost everybody has. What we're releasing here are support for reliable collections and reliable dictionaries, basically reliable services, using the same data structures that you're familiar with, except underneath the hood, Service Fabric is taking care of making them highly available and durable, using these microservices underneath. So reliable queues, reliable dictionaries, and let's go take a look at a demo, which you can get right from Visual Studio, of launching one of these sample applications. So if I go into Visual Studio now, when you get the SDK installed, you'll see Service Fabric here. And I can say application with stateless service, stateless actor service, and stateful actor service. I'm going to click on stateful service and press OK. And then we'll go take a look. This has one basically microservice that's part of it. Here's the application manifest. So remember I said everything is declarative. You can see that this has one stateful service. It's called stateful1. It is of type stateful here. And it's partitioned. I'll talk more about partitioning in a second. But we can go take a look at the code for this stateful service. And this code is right here. So this is getting a reference to a reliable dictionary, which is just a key value store. Here it's sticking it in my dictionary. And then what it's doing is getting the current value for the key counter 1. And then it's spitting out that value right here. So this will go into Service Fabric's diagnostic logs that we can see in a second. And then it's adding one here, and then it's committing this to transaction. So transactions are essentially transparent to you. You can perform multiple operations on multiple objects all underneath this kind of transaction, this create transaction. And then it's all either committed or not committed. So I can go update this object, do that one, minus this, say commit, and either the whole thing happens or none of it happened. And the failure cases are all handled automatically for you underneath the hood. The states are replicated to those replicas in a transactionally consistent manner. And that's how easy it is to write a stateful, transactionally consistent application with this API. Now let's go ahead and deploy this thing. So I'm going to deploy it by saying publish. Oh, actually, I need to say deploy. Actually, we just, oh, actually, I don't need to deploy it. So I've got a test cluster set up for this one, and the development cluster. And what I'm going to do is an F5, and Visual Studio. And what this is going to do is start to spit out those logs, those Service Fabric diagnostic logs right here into Visual Studio, the diagnostic events. So we're going to first see those microservices, that microservice and those instances, because there's going to be 3 instances deployed, come up. And then we're going to start to see counters here. So there's counter 1, counter 2, counter 3. That's the incrementing of that reliable dictionary key value. And I can go back here into Visual Studio, into Service, and I can get debugging of that stateful microservice right inside of Visual Studio. So I've just hit this. You can see I've got all my locals. I can step through it. And so this is distributed microservice debugging right from inside of Visual Studio. So let's go back to the PowerPoint, and let me talk a little bit more about some of its capabilities and show you some demos that are a little bit more impressive than running something in Visual Studio. At least I hope you find them. Microservice partitioning. We know that when we're in a scale-out world, we're dealing with data sets that are so large that we need to scale out, we can't scale up. And so partitioning is one way that helps us do this. Having client requests being routed to a partition of microservices. So I can partition my microservice namespace, and as requests come into a new partition, the microservice instances are automatically fired up by Service Fabric. So you can see here that I've got one partition with its primary and its secondaries, another partition serving the same service with its as well. And these get distributed just like any other microservices. Let's go take a look at some of these in action on a larger scale application. How many people noticed, just out of curiosity, that Scott Goo always wears a red shirt? Does anybody notice that? So it turns out a lot of people have noticed that, and there's a lot of people that have a lot of debate and discussion about which of Scott's red shirts are the best over the various events that he's spoken at. So we created an application that we're going to launch that's going to let people vote on which Scott Goo red shirt they like the best. And this is the composition. It's broken down into microservices. It's a web viewer microservice, a national service counting microservice, which counts up all the votes from all the counties in the country. Those county services are just keeping track of the votes in their own county, and then we've got voting services, which are generating votes. So this is kind of a load generator for the application. So let's switch to taking a look at this application. And what I'm going to do is open the website here. And you can see that I don't have anything running. But what I'm going to do is launch this. And this is the deploy election from package. So I've deployed the Scott Goo application. By the way, here's the Scott Goo application. And I'm going to deploy this and then come back and show you what's going on. Now, this is refreshing here, and this will come up in a second as that application of, this is being deployed, by the way, to microservices to 100 A2 VMs up in Azure, 10 D4 for the initial counties, 40 D4s for the count scale out, which we're going to do in a minute, 5 D4s that are doing the national service level, and 5 D4s that are the web interface. So this is a massively scaled out application running in Azure. It's going to be deploying microservices to this cluster to represent this application here in a second, and then you're going to see this fire up. And the votes start to come in. Let me do a little refresh here. And there we see build 13, build 2014, and the votes are coming in, and the counties are starting to light up with their preferences, so they're lighting up with the color for the majority vote in those counties. And if I go take a look at the code for this, I'm in the vote controller. Actually, let me go to the National Election Service here. Oh, yeah, here I am. And this is actually going to, down here, getting the reliable dictionary. This is the county vote count. If I click on this reliable dictionary county data, you can see that here's the structure. It's got its own dictionary of the shirts, and it's keeping track of votes per second per county. And this is doing a link query across all of the reliable dictionaries for all of the counties and doing a summation on them to show us the result by shirt, which is what we're seeing in the UX. And that's how easy it is. All of this is durably consistent, highly available, and that's a link query across the whole thing. Go back here. Now I go to the cluster view, and this is where things get interesting. Here's the cluster with all the microservices, with the custom UX that we've built to show you. And actually, this looks like it's might be still deploying. So here's the throughput of the votes that we're seeing. And this is going to continue to rise as we get more and more of these. Now, what I've done is set a placement constraint such that these microservices can only sit on these nodes. And I'm only looking at the county nodes, the ones where the county aggregators are sitting. What I'm going to do is lift that placement constraint. And I'll lift that placement constraint by first connecting to the Service Fabric endpoint. And then here, you can see placement constraints. I'm going to lift the placement constraint, F8. And now we're going to see this thing like spread out all over the place. We should see this start to go in here in a second. And you can start to see the microservices start to migrate. And in the fullness of time, give this another minute or so, we're going to see all of these microservices get spread out across the rest of the cluster. Just all automatically happening through the lifting of that placement constraint. And then remember, this is stateful data that's being migrated. All of those counts for those counties are being migrated as part of these operations. So that's a quick look at that. Let's switch back to the PowerPoint. And we have one last demo to show you. And this one is a Reliable Actors API. How many people have heard of Project Orleans? How many people have heard of the actor model, So quite a few of you. Now, the Reliable Actors API lets you build basically object-oriented microservices, ones where the state, the lifecycle management is all done by the actor programming management interface. You just worry about the object, and the objects talk to each other through messages, and the activation happens automatically. If I reference an actor that doesn't exist yet, an actor object that doesn't exist, an instance, the actor framework automatically instantiates it, and I don't have to worry about it. If it becomes idle, it gets torn down from RAM, and basically its state is persisted on disk. If it gets activated again, that happens automatically. We've written a little game to highlight this called Actoroids, where each object in the game, and this is kind of because Project Orleans is being used by Halo Online, where everything's an actor in Halo Online, kind of like this. Gateway is represented as an actor, the ship is an actor, the asteroids are each individual actors, and the laser beams or bolts are all individual actors. And the system all talks to each other through actor message passing. Let's switch back to the demo machine and take a look at this source code. And I've got Actoroids up here and running. Here's the Actoroid. What I'm going to do is publish this, deploy this, and right-click, deploy. And this is going to deploy this to Windows Service Fabric cluster that's already operating. And while that's launching, I'll show you the asteroid actor, which here in its activation method simply registers a timer that is going to call move asteroid. Move asteroid simply updates the position of the actor. And that's it. Now let me pull this game up. And to show you this demo, I'm going to bring Corey Sanders up. And we're going to play a little Actoroids. Okay, so
it's going to be amazing.
I think this is me and this is you.
That's
Corey Sanders.
The best part of the entire presentation is right now because I'm on stage.
Thanks, Corey.
They agreed. Oh, yeah. Sorry. We like you too. Thank you. Corey. All right.
All right.
They have no idea who I am.
Wake up your Xbox controller.
Am I in?
Oh, mine got disconnected.
Oh.
Wait, no, it's a wireless one. Oh, this is you.
Oh, that was an accident.
Yeah.
I don't see anything happening.
Yeah, I don't know what's going on with yours. Actually, this controller doesn't seem to be working either.
Well, you can imagine what it would be like if the...
It'd be really awesome.
That's really fun.
Actually, does the keyboard work?
Oh, I died.
The keyboard works.
Oh, okay, does my keyboard work? No, I'm moving your slides. I moved your slides all over the place. All right, well.
All right, can we get you back on the screen? Because I want to show you what I was going to do to you. And that's by updating this game live.
It's good thing I'm here.
Yeah.
Definitely.
Thanks, Corey.
This has definitely been worth my time. Am I done?
Yeah, you can go.
Well, thank you, everybody. Thank you. Corey Sanders.
All right, so what I was going to do is this. I've got a code snippet here that I inserted that is going to make the asteroids evil for Corey. He didn't know that. And then what I was going to do is I need to update the version of this. I need to set the assembly information to a new version so Service Fabric knows it's new. Then I'll come up to the application and I'll say build. And what I'm going to do is this is going to start a rolling update. So I'm going to say package. And I'm going to go to PowerShell now. And I'm going to say upload. This is just going to upload that updated version. We'll go back to the game. So we'll go to rolling update now that package is uploaded. And then that started a rolling update. Whoop. Did I start the rolling update? Here's the rolling update. And now what's going to happen here is these asteroids are going to start to turn red. And if Corey was up here playing instead of wimping out like he did, we would see the asteroids are going to turn red and start to follow his ship. So as the rolling update proceeds. And this will just take a few seconds. There we go. And what they're going to do is they're going to follow Corey. I think Corey's backstage playing now. And you can see that there's no pause to the game. These microservice instances, these actors are getting upgraded while we're playing the game and changing their logic with zero downtime as I continue to play the game. All happening again through the magic, and these are all stateful actors with multiple replicas. And so you get the idea. That's the game. All right, now one last thing he was playing backstage, all right. So one last thing I want to show you is a video from OSIsoft, which has been using Service Fabric for a while, and let's hear what they have to say about it. And then I'll give you some pointers to some other sessions, and we'll wrap it up. By the way, OSIsoft is operational intelligence company.
We've always known
here they
that
go.
Resources are not infinite. We look at California, what we're going through right now. We're going through a record drought. We need to manage the resources that we have.
What we're seeing now is just a giant explosion in the number of sensors. What we really need is a system that can provide insight over all this data that we're capturing. The only way to do that effectively is to have it live in a public cloud. Our new set of Pi system services will allow both the consumer and the utilities to gain insights and actually be able to manage these resources in real time.
Technology is critical in our business. We are data-driven. It's a critical piece for us that we get the right data in the right time to be able to use it effectively.
The Microsoft Cloud Platform and Service Fabric really enables us to capture the data from that proliferation of sensors and do something meaningful with it. What Service Fabric brings for us is a level of reliability and performance that we couldn't get by just using the standard virtual machine technologies. It provided a path for us to build new technologies within Azure and actually be able to bring them back on-prem as well, which was important for our customers. For the kinds of class of problem we're trying to solve, Service Fabric really is the only platform that makes sense for us to build ourselves. It would have been a multi-year actual undertaking for us. We want to concentrate on where we add value and leverage the platform that's already there.
All right, so let's switch back, and I'll give you a little bit of a roadmap into what you're getting today with Service Fabric, and then point you at some other videos. So today, languages are C++ and C#. We've got other languages coming. Operating systems, today is Windows. Linux is going to be coming. Containers, right now it's job objects on Windows. You'll see containers on Windows and Linux. And finally, integration with Azure. Today it's an SDK. There's the URL to the SDK, which is live now. And future, we'll have resource providers for Service Fabric that will make cluster management simpler. And then that basically takes me to through the whole stack. Of course, you want to get higher level. We saw web apps this morning in App Service as higher level programming model on top of the Azure Compute Platform that fleshes it out from high control to high productivity. And then finally, here are some of the other sessions that we've got that go deeper into Service Fabric, into containers, into Resource Manager, into the new V2 versions of these APIs. And with that, I want to thank you very much. I hope you have a great conference and have fun on Azure and with Service Fabric. Thanks.